Hey, Warren Poshman, your host and friendly local solutions architect, and welcome to this edition of This Old Architecture, here in our 1920 Quincy house just outside of Boston. You know, there's almost nothing more beautiful than a dumpster in the morning. In, boom, and gone. Demolition is almost done, and our dumpster is full of lath, plaster, 1920s armored BX cable, and more. Today, we're actually going to explore cloud native and frame out why that's important change for everyone. Over the past year, Voltage has been engineering has been busy in the workshop retooling and transforming the secure data product from an appliance based to one that's built on microservices that are containerized. So, what does all that have to do with plaster and lath, you might ask? The evolution Voltage has been on is a nice parallel to the journey we're on here in Quincy. Voltage is bigger and better than ever. So call it what you want, but to quote the wise rhymings of LL Cool J, don't call it a comeback. We've been here for years, rocking our peers. And to competitors, you know how that rhyme ends. So grab a pair of gloves and meet me inside where we talk cloud native today. Hey, so as I promised on this edition of This Old Architecture, we're going to talk about going cloud native. So it's not going to be all work, just a little bit of work. But anyway, we've all heard about cloud native, so might as well get right into it. Anyway, if you haven't actually heard about it, then this will be a great idea for you to take your organization forward. Cloud native is really a paradigm shift on how we work with everything, and we're making things for the cloud, not just putting things in the cloud. And the core idea is really to use and make things easier so everyone, every place can have more productivity, lower cost, and really get the business value from the cloud. So honestly, we've got a lot of work to do here, and going cloud native can be a lot of work for a lot of people because, like all technologies, it really takes a lot of time and adoption is not immediate. So it's something that has been driven by the Cloud Native Computing Foundation. Ultimately, here's the definition. It's a lot of cool stuff in here talking about containers, immutable infrastructure, loosely coupled architectures, robust systems that's manageable, observable. It's awesome, but in the end, what does all this really mean? So we already know everyone's going to the cloud. If you're not moving something to the cloud, if you're not headed into the cloud, then your workloads are not increasing, and everyone's workloads are increasing. So by definition, when you say I move something to the cloud, it's really shifting workloads into the cloud. It could mean a lot of different things. It could be moving an architecture up there, it could be moving an application up there, it could be moving the system of record up there or a database up there. But in the end, really what it's about is shifting from a capital expense to an operating expense and getting reliability and scalability, the long promised holy grail of the cloud. And for a lot of people, it's been hard to achieve because really what they're doing is they're focusing on cloudifying something. So moving things to the cloud and recreating the same thing in the cloud is not actually going to be giving you what you want. That's the cloudification. It's a first step. It's a step we all take, but the real benefits of the cloud are often not realized. Going cloud native means actually a redesign for the cloud, and you're trying to maximize benefits. So the additional benefits you're going to get are going to be long-term, not the short-term that we get with cloudification. So a fundamental example, if you look into cloud native, have a discussion about it, eventually Netflix is going to come up. And especially if you've been on the planet for the last year, undoubtedly you've watched Netflix in some point or other. So back seemingly 10 plus years ago, in 2009, Netflix was at the verge of becoming what it is today. It was literally a Blu-ray and DVD delivery service, not the content delivery network that we see today. So really, in the end, it needed to move, it needed to enhance itself because the architects at Netflix realized that they had some serious problems in reliability and performance that were lurking. They knew that if they went all streaming, that it was going to come back and it was going to be a problem. So effectively, they pioneered what we would call cloud native today. They used things called containerization. They used microservices. They really did the first POC. And Adam Cockcroft is really the person that drove all this, and he's one of the fathers of really what making cloud native possible is. So definitely there's lots of people out there that did this, but Netflix is a great example of someone that took it and actually made it happen. And at the time, people told Netflix, it'll never happen, it'll never work, you're ridiculous, I'm not going to do this, it sounds like a science experiment. They proved that it actually works, and today it's how we can all watch Netflix at the same time. So really, the cloud native retool process is how we're going to get the most value from the shift. It's not going to be just moving things there, because what we want to do is we want to take large, complicated, monolithic systems and apps and infrastructures out. We don't want that. We want instead microservices that operate in a container, independent, without something like this heavyweight, like an entire operating system. And we also want to have interconnectivity, because we can't just have a service operating on itself. It needs to be consumed. And that's going to be a well-defined API, because that gives us the ability to develop against it. And it's something we hear all the time. We're talking about continuous improvement, continuous deployment. And that's actually what we are trying to strive for, is making it easier, making the servers, the applications, everything a smaller piece, and then making it into something we can make lots of it. So does it sound familiar? It should, because it's really like an industrial revolution for IT. And in fact, that's why we're here today, because it's really a nice parallel to where we've gone through in a lot of things. It's not just IT. So if you have owned or lived in a house before 1950, undoubtedly the way the house was built was it was framed out, and then you'd have a crew come in to put up the walls for you, and they would hand nail lath and to all the studs and joists, thousands and thousands of these little tiny nails and these long strips of wood, just like you see here behind me. And then after all that lath was done in every room, then crews that would do the plastering would come in, hand mix all that plaster, which is consisting of lime, sand, and a binder, which they call it horsehair plaster for a reason, just saying. But anyway, after that, they would apply 3 coats, and finally you'd have the wall that we all are accustomed to walking in and seeing. But in order to do that, make it resilient, they had to push that plaster through the lath and create what we call keys, which is what you see here, where the plaster is hanging on the backside. But the finished product was excellent. It was withstanding, and in fact, there are plaster walls that date back to the Egyptian times that are still in existence. It's that resilient. But it took a long time. It took weeks. It could take months for an entire house, depending on weather, depending on crews, depending on materials. So it was a lot of pieces moving. In order to build all this, it took us a lot of time. So, not to mention probably a lot of horses too. Anyway, point is that improvement is a constant thing, and this is a great example of how we took this process and we containerized it. In approximately 1950, drywall was created, and blueboard, which is the basis of what we have for modern plaster walls today, was created to be able to allow you to put up an entire room in a day and then skim coat it with simply a quick process to make the process that could have taken weeks and months down to a matter of days. So without the amount of labor, we were able to also reduce the price, because we would be able to not only build one house, but we needed to build hundreds, thousands of houses, because the post-war boom in America required that many people. Everyone wanted a house that they could live in. They wanted a new house, and there was only one way to do it, was to reinvent ourselves. And the way we could do that was by buying finished materials that we could assemble into the piece that we wanted. So instead of building it ourselves, we bought these, we containerized it, and we were able to deploy almost an entire house, if you will. So, hey, it's not all about plaster, but cloud native is a similar process, and that's why it's interesting to think about it in that way. And the containerization that we do today, it's actually more than that. It's actually a whole bunch of things we have to have. So there are lots of components to a cloud native deployment infrastructure, but there are some key ones. The first being containerization. It's really the basis. Docker is what most people use, and there's a good reason for it, because it allows you to operate without having the entire operating system. that's a great boon. You don't have to worry about all the vulnerabilities, all the problems, all the changes. If you need to deploy something, you can make a quick change, get it out the door immediately. So that's great, but then how do you make it work? You have to orchestrate it or be able to figure out how you deploy all these containers. So it's just like having a whole palette of Blue Board. You've got to have someone that's going to put it up and knows how to put it up and where to put it up. So how is that done? That's done with an orchestration platform. The biggest one that's out there today is Kubernetes, or sometimes you'll see it K8s. It's a great thing to read up on how they got that name. It's a totally arbitrary name. They tried to create a name that sounded like what it should be, but the Cloud Native Computing Foundation, this is their cornerstone product that they support, and it's really driving the cloud native architectures today. So, of course, you have to have monitoring. What good is it if you can't know what's happening? And so that's really what's the key thing, is being able to containerize, deploy, and monitor. And then, of course, you have a set of tools that you're going to be using to, be able to see what it looks like. Everybody likes to see a nice chart, a nice picture, and so these sorts of tools give us that visualization. So it's just like with data, we need data visualization tools. Well, for cloud native, you need a visualization tool. So by all means, there's lots of ways to do this, many different products that allow you to get there, but these are some of the core ones that are part of it. So there's also some great benefits on the developmental side. So with the philosophy of cloud native, the application developer really gets what he's always wanted, he or she, or in any case, they allow themselves to be able to be focused on doing their work and making things instead of figuring out how to hook everything out together. So faster development cycles, easier development in the language of your choice, giving you that CI/CD pipeline that we all hear about, we all talk about it. How do we accelerate this? And this is how you can do it without having your developer get bogged down in all of the little pieces, to focus on the big picture. So in the end, the software design lifecycle is intrinsically improved, and the side effect is that you can retain top talent because you get developers, they get to choose how they develop and what they develop instead of worrying about all the other pieces that cause stress and project delays. So this is just yet another way of developing on cloud native. The advantages really come home. So the operational benefits, of course, are really what it's about as well. Containerization is really part of that. And as I said, it's a way of taking away all the hard parts of the operating system, just bundling in only what's absolutely necessary. So similarly to how a virtual machine abstracts the hardware level, this gives you the ability to focus only on the components that are required to abstract kind of the application layer. So Kubernetes then can pick this up and have automated, scriptable. These deployments can be done without the need. So let's say you need more servers, you can have Kubernetes automatically deploy them once some metric is met. Maybe it's utilization, maybe it's workload, whatever it is. These can also recover and make these sorts of manual deployments not possible, or not a thing of the past, but in the past. So it is actually the greatest thing, is that giving you the ability to not only deploy and manage, but it's a small piece. So if one of the pieces in the middle breaks, it can be easily replaced, and that's what we call making it immutable. So it's not like you have to open the entire system up. You get to deploy something. If it malfunctions, you get to redo it without undoing everything else you've done. So the ability to monitor the resource utilization and making it scale, we don't actually call it monitoring its observability, but it gives you the ability to make that capacity change instantaneous without having to have an administrator make a change, right? So the obvious problem we have with outages, with capacity, these can all be things that are part of the past. And so in the Kubernetes sense, all this is going to be deployed in a pod, and it's going to execute on a various set of nodes. You have lots of pods that are running different services that are containerized. You can kind of see how it all fits together a little bit, but in essence, this gives you the way to deploy exactly what you need to get exactly the type of business throughput you need. Another great example, if you're not aware, is the meetings company called Zoom. Now, Zoom obviously was a company that everyone's heard about today because everyone's talking about how they're using Zoom during the pandemic, but the point is that it got there because of its cloud native heritage. So not that long ago, Zoom had somewhere around 10 million daily participants. There's a little bit of controversy as to what they call a participant or subscriber, whatever it is, but there was about 10 million users that were going into meetings a day. But mid-2020, we know exactly what happened. Everything went online. Everyone was out of school, was out of their job in the home office. It was a dramatic shift almost overnight in some cases. So their subscribers boomed to 300 million. Not, it's not a tenfold, it's like a 30-fold increase, right? That's crazy. And there's no way you can do that by simply deploying more servers manually. You have to be able to build it on an approach that allows you to scale automatically, because it's impossible to know how many people are going to be online. And of course, with video content, it has to look good. And by and large, the video that people experience on Zoom is very nice, high quality video. So some of the competitors had cloudified systems. They weren't able to scale as quickly. They had legacy architectures that they had cobbled together rather. And so really the product features and quality were one thing, but this expansive growth would only have been possible with the architecture that allowed them to scale quickly and move into additional capacity without having to make any substantial major changes, new deployments. So it really shows you, though, one thing, if anyone heard about Zoom bombing, other problems, is that security is a dramatic increase whenever you have this much additional growth. So the concept of going cloud native is great. The impact of going cloud native is you have a lot more of great. And unfortunately, that means you have potentially a lot more of things that people want access to, and perhaps sensitive data. So sensitive data means security, and we know that that is important today. So really, security, data protection, and privacy, it all has to work with cloud native. We can't have it without it. And so, there's vulnerabilities everywhere. Kubernetes has vulnerabilities. Docker has vulnerabilities. Containers themselves have some vulnerabilities. So there's, a lot of things happening in real time where the system is making decisions for you. And so we want to make sure that those decisions are, secure. And those containerized components are obviously running on a shared OS. So your data is also running on that shared OS. So even though the container is in a full OS, somewhere behind there's an OS that's running all of that. We have to make sure that that's not only safe and secure, but that it gives you the amount of workload that you can do. You can't have scaling if your security can't scale with it. So from a perspective, the need to protect data and privacy is even more acute than it's ever been, because we really have an automated way of making productivity. We have to make sure that the security goes with that productivity. So those shared resources, the security that goes behind it, we've got to find a way to do it. Of course, us here at Voltage Security, we've got some great ideas as part of the Micro Focus Cyber Res. That's, really the way that you scale security has to be cloud native, right? If your applications, your resources are all hyperscale, then your security needs to be capable of doing that. So one of the things we can do is protect data as far upstream as possible. So using technologies like Voltage, format preserving encryption, format preserving hashing, or tokenization, we can then protect data, and such that when it gets into other resources that are hyperscaled, it's already protected. So that's obviously a great thing. We don't have to protect necessarily always in real time. We can protect upstream and benefit from those security measures downstream, because it's data-centric security. So whether it's on-premise, in the cloud, or cloud native, this is definitely going to give you that security, even if it's shared, leaked, or stolen. Hyperscaled resources really have the ability to work on data that's de-identified as well. Because of the way that data-centric security works, it doesn't matter whether the data is the original data or whether it's the format preserved version or tokenized version, because in those cases we have referential integrity, giving us the ability to perform analytics and use the data just like it would be. So there's no need for those hyperscaled resources to always operate on the original data. So if we can purge that from there, we can assure ourselves of greater security, because we don't have to worry about where is sensitive data, because we can know that the dynamic transparent protection can remove that, and it'll make it such that there is a lesser security risk with more resources, if you believe that. So there's a lot of work we have to do sometimes, but to get there and make our CI/CD pipelines, like lower risk, this is really the goal. It's just that we can make more resources that are more secure because they can operate on protected data. So secure data, for those of you that have used it, traditionally has always come in an appliance, which is a monolithic system with an operating system with an ISO that is created and produced by Voltage Engineering. So in here, actually, it has some microservices of sorts in it, management, other types of services to do with key management, tokenization, and like event amalgamation. So by deploying the Voltage appliance, you could then deploy additional resources, but you have to deploy the entire appliance. So if you want a kind of a uniform performance, this is great because every appliance is going to have all these components. You can toggle which of them you want on or off or enabled. So therefore, it's a way of making an architecture that gives you the right capacity for the entire organization. So you can have enterprise-wide data protection. But if you need to deploy another, then it's a problem because more of these require some sort of administrative intervention, and more of these require monitoring and other administrative actions. That's actually the problem, is that we can't decide on Black Friday we need more. We need to be able to be ready for that so that when our Black Friday volumes come up, we can scale immediately. So how do we do this? Of course, secure data needs to go cloud native, and it has. In order to enable sort of that journey that you're undoubtedly on with cloud native, the Voltage SecureData Service product is really what the answer is. So it's cloud agnostic. It allows you advanced authentication methods, and of course you get that granular event tracking that we all need when we have hundreds of instances going down. So taking the appliance and breaking it down into multiple services is going to not only help you to deploy faster, but it's going to allow you to tune to be the exact resources you need. You need more key management services, you can deploy them. If you need more web services, you can deploy that. It depends on how you need to scale, and Kubernetes can give you that ability to do it quickly and efficiently without having to make administrative decisions. So that not only gives you the ability to deploy that in a single pod, but you can deploy that across multiple Kubernetes nodes and cover an entire infrastructure across the globe. It's as simple as being able to configure the services you need and then let Kubernetes scale them as necessary. So what actually is the Secure Data Services? Well, it gives you a minimalist kind of individual Docker containers, just as you would expect from a cloud native infrastructure, and you get to run this on Kubernetes. And there's several services here that give you the ability, like I said, to break it down and deploy it as you need it. So without having this, you would have you wouldn't have the redundancy, you wouldn't have the scalability. But of course, once you've got all this in place, you can have that because you don't have to have one service or one appliance. You can have as many as you need. So really, in the end, it gives you the ability to have that capacity-driven footprint that allows you to pay for exactly what you need and operate independently and communicate securely across all these services. So it's a whole kind of infrastructure that talks to each other, once again, using those APIs, because we all know that being able to talk to the service is important. So having these APIs that allow each service to share data amongst themselves give you the ability to scale and give you those powerful distribution that you need across the globe. So really, where does this take us next? So, here next week, Mike Edelman from Neponza Plastering is going to be in here to throw up some plasterboard, and that's going to finish this. But on your cloud native journey, you've got a lot of work to do if you haven't started. But Secure Data Services can really dramatically help you scale that security along with the rest of your workload. So you've got applications and systems that are scaling. Make sure that you include the security with that. With the simple scriptable deployment, you can manage, you can monitor, and with Kubernetes, it gives you the ability to visualize all of this across any platform you have. So if you're thinking about retooling, and I guarantee you almost everyone is, or they're already in the process, the traditional appliances can still be used though. So if you're still trying to get there, of of course, the Secure Data Appliance is still there for you. But of course, next coming up is really the way that we're going to scale, or the way we're going to move security forward, is to be able to do it in the cloud native fashion, and we're here to help you with that. Hey, and that's all for today for our edition on going cloud native. And so I hope you enjoyed it. I hope you got something good out of it. And remember, going cloud native is the best possible thing you could think of doing, and scaling that security is uber important. So for this old architecture, I'm Warren Postman, and it's time to get back to work.